Hey y'all, it's Miss A. Today we are moving on in Unit 6 and we are getting into prime factorization. This is honestly one of my favorite things to do. I don't know why. I just always have found it, not fun, but I don't know. I just always liked it, along with solving equations, which we're going to get into in Unit 7. I'm a math nerd, I know. Anyway, so today prime factorization is all about just figuring out what prime numbers multiply together to get an even bigger number. All right, I find it pretty easy. The visual that we use to help us find the prime factorization is extremely helpful. Okay, so let's get into some vocab first. You will need these vocabulary words for your quizzes today, okay? So it's very important that you have these to refer to when you are working on your assignment today. All right, a prime number. Okay, hopefully you remember prime numbers from elementary school. Prime number is a whole number greater than 1 that can be divided evenly only by 1 or itself. Okay? Basically what that means is the only way you can multiply to get the number is to multiply 1 by that specific number. So the first few prime numbers that you need to know and memorize are 2, 3, 5, 7, 11, 13, and 17. You need to know these. There are more prime numbers, like there's a big list of them, but the ones you're going to see the most are these right here, okay? So if you can memorize these 7 prime numbers, then you should be pretty good, okay? Again, prime number just means that the only way you can multiply to get this number is to multiply 1 times itself. So the only way I can get 2 is 1 times 2. The only way I can get 3 is 1 times 3. The only way I can get 5 is 1 times 5. That's the same case for all of these. Let's do 12 is not a prime number because I can do 1 times 12. I could do 2 times 6. I could do 3 times 4. Okay, there's multiple ways I can multiply to get 12, making it a composite number, not a prime number. Okay? Prime factorization is finding which prime numbers multiply together to make the original number. Prime factorization is finding which prime numbers multiply together to make the original number. To help us find the prime factorization, a factor tree is a way to organize and help you determine prime factorization of a number. Okay, this is what we're going to make every single problem to help us determine what the prime factorization is of a number, of a composite number. Again, like I mentioned earlier, you do need to know these 3 things: prime number, prime factorization, and factor tree. They are going to be asked to you on your quizzes. They're going to give you the definition. You're going to have to fill in, you're going to have to answer which one it is. Okay, so make sure you have those written down. Now let's get into the example of a factor tree. So you can see here, it gives you kind of like a little step-by-step. It says write the number, which I have written for you here. Sorry about that shadow, guys. Write the number. So in this case, it's 90. And because we're making a factor tree, a tree has branches. So you're going to start off by drawing 2 branches going off of the number. You always put 2 branches, never 3, always 2. All right, it says choose any factor pair, but do not use 1. We don't want to use 1 because if I put 1 here, 1 times 90 is 90. I'm going to have the same number repeat twice. Never, ever, ever use 1, okay? After we do that, it says if one of the factors is prime, we're going to circle it because prime numbers can't be broken down any further. So we're going to circle it. We can stop. And this is kind of small. If one of the numbers is composite number, continue to choose another factor pair. So we're going to draw another 2 branches off of every composite number. All right, so let's get started. So the number is 90. So we need 2 numbers that multiply together to get 90. Now, me, being a math teacher, I know that I can do 45 times 2, I could do 10 times 9, I could do 3 times 30. There's a lot of options that you can choose. You might not know all of those. You might only know 1. You might not be able to think of any in the heat of the moment. But what you can use is your handy dandy multiplication chart. Now, this multiplication chart won't give you every possible list of factors necessarily, but it will hopefully give you at least one. All you have to do is find the number that you're breaking down somewhere. Don't find it here on the side. That's not going to help do any good. You need to find it somewhere in the middle, okay? So the number is 90. Here we go. So the two factors of 90 are straight up 10 and straight over 9. So I'm going to put 10 and 9. Doesn't matter which way you put it. Doesn't matter at all. You can put the 9 first. And what I like about prime factorization is that, or factor trees, is that you could use 45 and 2. You could use 30 and 3. In the end, we're going to get the same answer, no matter what, okay? As long as you do it correctly. All right, now neither one of these numbers are prime. They can both be broken down. So I'm going to draw 2 branches from the 10, and I'm going to break it down, okay? I know, again, you could use your chart if you need to, but I know that 2 times 5 is 10. 2 times 5 will get me 10. The numbers at the bottom of the branches will always multiply together to get the number above it. Okay, that's actually one of your test questions, I believe, is they give you a whole full factor tree with one number missing, and you have to find it, so just multiply 2 times 5 to get the number above it. If this number was missing, I would multiply 10 times 9 to get 90. All right, now 2 and 5 are both prime. They're on my prime list up here. Have this to refer to if you need to. So I'm going to circle it. It says here to circle prime numbers because I can't break it down anymore. All right, 9 is not prime, it's composite. So I'm going to draw 2 branches and I'm going to figure out what 2 numbers multiply together to get 9. Again, use your chart if you need to. But I know that 3 times 3 will get me 9. Okay, 3 is a prime number, so I'm going to circle both of those. And there is nothing left to break down. I can't draw any more branches because every number that's remaining is prime. So now I'm going to put these numbers in order from least to greatest. They have to be in order from least to greatest. So I have a 2, I have a 3, I have another 3, and I have a 5. Now remember, we're doing prime factorization, which is the prime numbers that multiply together to make the original number. So I'm going to put my multiplication symbols in between them. So what this is saying is that I could multiply 2 times 3. Then I could multiply by that by 3 again. So 6 times 3 is 18. And then multiply 18 times 5, and I will get the number of 90. If I don't get 90, then I messed up somewhere. Okay? And then going off what we learned yesterday, we can express this using exponents. So technically this is correct, but we do want to write it using exponents. So we're going to put or. So there's only one 2, so I'm just going to put 2 times, but there's 2 3s, so I'm going to put 3 to the 2nd power, not 3 times 3. Remember, the exponent's how many times you see it, and then 5. This is how you're most likely going to see it on a test, quizzes, IXL, whatever it may be. So make sure you know how to write it using exponents. All right, let's do a couple more. Number 1 is 120. So we're going to begin by writing that number here, and we're going to draw 2 branches. Again, if you don't know what 2 numbers multiply together to get 120, hopefully it's a number that you can find on here, which in this case it is. 120 is right here at the bottom. So 120 goes straight up, we get 10, goes straight over, and we get 12. Oh, you can see the top. So 120, 10, and then straight over was 12. So 10 and 12. Again, if you flipped them, it's okay. All right, neither one of those numbers are prime, so we're going to break down them one at a time. I'm going to start with 10. I know that 2 times 5 will get me 10. All right, so 2 is prime, 5 is prime. I can break down 12. I could do 6 and 2. I could do 3 and 4. It doesn't really matter. I'm just never going to use a factor of 1. Let's do 3 and 4. All right, 4 is not prime, but 3 is, so I'm going to circle it. And then I can break down the 4 into 2 times 2, which are now both prime, and I am done. I'm going to list these numbers in order from least to greatest. Now, and I'm only listing my circle numbers, not anything else. I've got 3 2s, 1, 2, 3. Then I can cross them off as I place them so I don't use them again. Then I have a 3, and then I have a 5. All right, and then let's write it using exponents. So there's multiple 2, so that's 2 to the third power times 3 times 5. And that's it. All right, one last one. Why don't you pause the video and try to do this one on your own and see how well you do. And when you're done, unpause it and see if you got it correct. All right, so we're finding the prime factorization of 56. So I'm going to write 56, and I'm going to do 2 branches. Again, if you don't know what 2 numbers multiply together to get 56, that's okay. Hopefully you do. But you can look here. Remember, it could have multiple ways to get it. You only need to find it one time. So I actually notice there's 2 right here close together. Doesn't matter which one you pick. I'm going to pick this one. All right, so we're going to go straight up 8 and straight over and get 7, because 8 times 7 is 56. So I'm going to put 8, I'm going to put 7. Remember, you can flip these, it doesn't matter. Or your factors could have been different, it doesn't matter at all. All right, so we are going to break these down. Well, I know 7's prime, so I'm going to go ahead and circle it. 8 is not, so I'm going to break that down into 4 times 2, not 4 and 4, that's 4 plus 4 is 8. Okay, remember you're multiplying. 2 is prime. Break 4 down into 2 times 2, which are now both prime, and I'm done. I can't break down anything else. I'm going to list these in order from least to greatest. Here's my 2's. I've got 3 of them. 1, 2, 3. And then I have 1, 7. So with exponents, that is 2 to the third power times 7. And that's it. Now, I did want to address really quickly one more time. Remember that if you have a number missing in a factor tree, okay, and there's branches underneath it, all you have to do to figure out that top number is to multiply those 2 branches together, okay? So if the 4 was gone and I had these 2, I could just multiply 2 times 2 to get 4. If the 8 was gone, I had these 2, 4 times 2 equals 8. If the 56 was gone, all I have to do is multiply 7 times 8, and I would get 56. Okay? Hopefully I'll find this pretty easy. I did want to address one more thing you're going to see on your quizzes. I forgot to put on the notes, so we're going to flip over just really quickly. Sometimes you're going to be given the prime factorization. So we have 3 to the second power times 11. And we want to figure out what number this is. What is this the prime factorization of? So what I have to do is actually solve this problem. So 3 to the second power is not 3 times 2. It's 3 times 3. And then the 11 is just one of them. So now I have to multiply 3 times 3 to get 9. Multiply that by 11. 9 times 11 equals 99. So this is the prime factorization. This is the prime factorization of 99. All right. One more example of that. So if we had 2 to the second power times 3 to the second power. Now I want to know what is this the prime factorization of. So I'm going to write it in expanded form first. 2 to the second power is 2 times 2. This is the only exception that's actually the same. Multiplied by 3 to the second power, which is 3 times 3. So I'm going to group these. I'm going to group these. 2 times 2 gets me 4. 3 times 3 gets me 9. And now I have to multiply those 2 numbers together. 4 times 9 equals 36. All right, so you are going to have that on your quizzes today. It's also, I think, on your test as well. But anyway, so that's just working backwards. They give you the prime factorization. You actually have to write it out in expanded form and then multiply all the numbers together. All right. Hopefully y'all like prime factorization as much as I do and find it easy. If y'all have any questions or need help with anything, please contact me on Zoom or email in Canvas. Y'all have a great day. Y'all do have a quizzes to work on today. Make sure you get that quizzes and the previous 2 quizzes from Wednesday and Tuesday of this week. All right, we're back at school after Christmas break. Let's stay on top of it and get things done as quickly as possible. We don't want things to build up. Y'all have a fantastic day, and I will talk to y'all soon. Bye, guys.